Hope I am audible. Can you please reply whether I am audible or not? Okay, let me start. I think I am audible. Okay, so in this video we are going to discuss few problems on active filters, and these problems are taken from different exams, mostly GATE exam papers, and also I'll be discussing one problem from one reference book, and that I will discuss in detailed way toward the end. So this video will be useful for those people who are preparing for GATE exam or other exams, as well as who are taking preparation for exams, semester exams. Okay. So let me take the first problem. So this is our first problem. So can you solve this one? Good. So in this problem you can see that one current source is mentioned here. There is one op amp and one energy storing element inductor and resistors are there. And obviously I feel that you know about active filters. The active filters are nothing but the filters designed with active devices like op amp or transistors. So mostly here we will be discussing the filters designed with op amps. So here we have these two elements, inductor and resistance. They are connected in parallel and it is connected in feedback path of this with this op amp. This will provide a negative feedback, so it is a stable one. So this problem is just to find out the type of the filters. Okay, whether it's a low pass filter, high pass filter, band pass filter. Okay, so how to check that one? So this kind of problems are coming frequently in GATE exams. So this problem is taken from the GATE paper 2011 ECE. Okay, just to identify the type of the filters. So how to identify this thing? So whenever you will be having one energy storing element like capacitor, its reactance you understand. If its capacitance is C, its reactance is 1 upon omega C or j omega C. That magnitude part I can consider. So it is 1 upon omega C. So you can see that when omega is very large, this 1 upon omega C will be very small. Okay, and when omega is close to 0, Xc is becoming infinite. So you can note that omega tends to 0, that time Xc will move, mod Xc will move towards infinity, and when omega tends to infinity, that time what is happening? Mod Xc moving towards 0. And reactance infinite means high impedance offered. Okay, means open circuit. This is nothing but open circuit. And when reactance is offered by 0, that means it's short circuit. So in simple manner, capacitor with DC. So for this capacitor, in DC circuit means low frequency. So low frequency, this one, it will behave as open circuit. And for AC, this will behave as short circuit. So this is very simple concept that we understand, but it is most useful to identify filter types. So how to use these things? So this is for capacitor. For inductor, it is just opposite. For inductor, what is that? For DC, it is just opposite. It is a short circuit. And for AC, it is open circuit. So be careful about these two things. Very simple concept. Now can you tell me what kind of filter it is? Anyone can respond, please? What type of filter it is? So there is an inductor here. So this inductor, this XL, mod XL is nothing but simple omega into L. Okay, so when omega equal to 0, it is 0, means short circuit. For DC, it is short circuit, right? And for AC, it is open circuit. So just tell me, if you apply a DC current source, this is a current source, right? So if this current source is DC1, if it is a DC1, that time what is the corresponding output? This output is high or low? Anyone can tell me, please? If the current source is DC current means zero frequency, that time what will happen in the circuit and what is the output voltage? So you can see that for DC, this inductor is behaving as short circuit. If it is shorted, the full current will pass through this side, it is fine. But there is no potential drop across this one. So output voltage will be simply 0. Is it fine? Because inductor is behaving as short circuit, it is shorted to ground. This is ground, virtual connected ground. So this output is also grounded, okay, shorted to ground. So output is 0. So for low frequency, output is 0. But for high frequency, this inductor is open circuit. So one potential will develop across this one. This is plus, this is minus, because current is flowing this side. So you will be getting one potential drop, and that potential will be this II times R1. So for AC, what is happening? The potential V0, it's something II times Ri, and that is more than 0, some high value. So for AC, we are getting high value. For DC, we are getting 0 value. So that means AC signal, high frequency signal, can easily pass through system. Low frequency is not allowed. Am I correct? That means it is a high pass filter. High frequency can easily pass, low frequency cannot pass through this thing. Okay. So this one, you can find out the expressions, everything. That we'll do later. We'll take more problem to calculate the cutoff frequency, everything. But this problem was just regarding the type of the filters. That we can do easily. Just we will go with two things. First we will try with DC signal, means 0 frequency, and next one we will go for very high frequency, means omega equal to infinity. Then we will see the output. If output is 0 or non-zero. If output is 0, that means that frequency is not passing through. But if output is high, that means that signal can pass through. Just checking these two, you can guess whether it's a low pass, high pass, band pass. Very simple concept. Okay. So I'll take more problems. The next problem. So can you solve this one? So can you solve this thing, this problem? What kind of filter it is? Simply you need to find out whether this is a low pass filter, high pass filter, band pass filter, or band reject filter. Okay. So I have said that we need to try with two things. One, when omega equal to 0 means DC signal, and next one, omega tends to infinity, AC signal. What is the output? Okay, for DC, inductor open, inductor short, capacitor open, and for high frequency AC, it is just opposite. Capacitor will behave as short circuit and inductor open circuit. Okay, so can you just rewrite or simplify this circuit, this one? So this with omega equal to 0, inductor shorted. So what is circuit now? Equivalent circuit. So this inductor will make it shorted. Okay. This is grounded. And this one, you can see that this is resistance is fine, but this capacitor is made open. This is the output. This is negative. This is positive. This is your VI. This resistance is R1. This is R2. So for DC signal, inductor is shorted here and capacitor is open circuited here. So what is the gain? What is the gain? So gain value, right now it is simple, one inverting amplifier. So it is minus. So this is not there, capacitor is not there, inductor is shorted. So it is simple R2 by R1. This is again. So this is finite value and some value is there, constant value. Okay. Now if we consider this just opposite, if omega close to infinity, so what will happen? This resistance and inductor will behave as open circuit. Then this is op amp. And capacitor will behave as short circuit. This capacitor is shorted. So what is the output? So this is your input. So you can see that here it is disconnected. So no signal can go through this side. So and again further it is shorted to ground. So obviously output is perfectly 0. Okay. So for very high frequency, output is perfectly 0. Very low frequency for DC signal, output is high because R2 by R1, this ratio is suppose made high. So this is for low frequency, it is passing through. High frequency, it can't pass. It will not allow the high frequency signal to pass through. Okay, that means it is a low pass filter. Low frequency can pass, high frequencies are rejected, so it is a low pass filter. Okay, I hope this is very simple, but we will be discussing more difficult problems. Okay, so next one. I'll discuss this one, but this is actually, it is not a active filters. There's no op amp connected or other transistors, but this is about the filter types. That's how I have collected this problem. So this problem appeared in GATE 2007 and previous problem. This problem was taken from GATE 2008. So these are all GATE papers, ECE papers. Okay, so you can see that these are all relevant papers. It is not that it is this kind of the problems I am discussing, it is too easy and it won't come. So this kind of problems are coming in GATE exams. Okay, now let us try with this one. So can you tell me what kind of filter it is? Very quickly. Okay, so we will try with these two things, one for DC and one for AC. As this system is having only capacitors, So capacitor will block the DC. Capacitor is open. So what is the circuit now? Equivalent circuit. So this capacitor is open. This is the resistance. This capacitor is also open. So what is the output? This is your input. So you can see that here it is open. So this current is 0. No signal can go through. So obviously output is 0. Okay. So for DC, perfectly DC signal, output is 0. It can't go through. Now for very high frequency AC, capacitor is short circuited. Okay. This is the resistance. This capacitor is shorted now. And this is the resistance. This capacitor is also shorted now. So what is the output? This is your VI. So okay, signal can go through here, current will be some non-zero, but as this one is shorted, so output is going to be 0 again, short circuit output is 0. So because capacitor is shorted, that's how across the capacitor output will be 0. So for high frequency AC, again output is 0. So for DC output is 0, for high frequency AC is also output 0. Some mid frequency we may get certain non-zero output. Okay, very logically we can think that its characteristics could be like this. Very high frequency it is high frequency 0, low frequency 0. In mid frequency I can get this kind of plot. So this is the gain h of j omega, its magnitude. So it will be a band pass filter. Okay, so without computing exact expression, we can find that it is a band pass filters. So this question appeared in 2007 ECE. Okay, so you can see that in GATE papers, sometimes very easy questions are coming from the filters just to identify the filter types. But sometimes the questions are coming very difficult. Okay, next we will tackle few problems which are more complicated. Okay, let us consider this problem. So can you solve this problem? So this problem appeared in GATE ECE 2014. Okay. This is a paper. Now, can you solve this thing? Now, it is already mentioned that this figure, can you identify this figure? It is obviously a low pass filter. Okay, because R and C connected in feedback path, and this is only the R1. So it is a low pass filter, it is already mentioned here. Its cutoff frequency is 5 kHz. Now we need to find out the expression for R2. Okay, R1 is already given, the 1 key. Now here we need to understand how cutoff frequency is decided for this kind of low pass filters, inverting type of low filters. Okay, so can you find expression for this one? Okay, so just it's not very difficult. I will discuss it very quickly. This is negative, this is positive, this is grounded. Okay, this is your capacitor, and this one is your resistance. Resistance R, capacitor C suppose, and this is suppose R1. So what is the expression for V0? This is your VI. So what is the gain? So V0 by VI, this gain will be, so this block, its impedance, if I call it Z2, and its impedance. So first in terms of S. So capacitor, its reactance 1 upon Cs Xs, we can find out 1 upon Cs. We can replace the capacitance reactance is by 1 upon Cs. Okay. So you know that it is a simple, this is op amp, inverting type amplifier. So it is minus Z2S by its impedance is suppose Z1S. It is Z1S. This is very simple. Z2S upon Z1S, that is the gain factor. So what is the Z2S? So this parallel combination of R and C. So it is R times 1 upon Cs by R plus 1 upon Cs. So this is your Z2, parallel combination of R and C. And what is your Z1? That is nothing but R1. And we have one negative sign. Okay. So if you simplify it, what you will get? This simple R upon R1, one negative sign, pi 1 plus RCS. Okay. So this will give you the gain minus R by R1. But this one I can write. So any transfer function H of S can be written as some constant by 1 plus S by omega C. That is a form of low pass filter. So if it is a low pass filter, it should have a pole. Okay. And cutoff frequency will be of this form 1 plus S by omega C. So if you compare this thing and this one, so what is omega C? So omega C is simply 1 upon RC. So this is very, very interesting. What I am saying that, so cutoff frequency will depend on this network, this RNC. It does not depend on this network, this resistance. Okay, so in this case, omega C will be simply 1 upon R2 into C. Is it okay? So what is R2? So R2 is nothing but 1 upon omega C into C. And omega C is angular frequency. So if I want to compute with linear frequency in Hertz, we should multiply 2 pi, then Fc, and it is C. Is it okay? So can you calculate the value for this R2? Anyone? What is the value for R2? So if you replace everything, Fc equals to 5 kilohertz, C is given 10 nanofarad. So 1 nanofarad is 10 to the power minus 9 farad. That you can replace. So what you will get? Anyone can make comments, please, if you are getting the answer. Can you compute? Please try to compute with me. Then you will learn better. Just watching the video is not sufficient. You should take your pen and paper and you should calculate with me. Okay. What is the value? I think it's very easy. So you can replace this omega in Fc and C. So if you replace this one, this 5K, 5 into 10, and this is your 10 nanofarad. So I think you will be getting around this 10 by pi times 10 to the power 3. Okay. That much ohm, that means 10 by pi, it will be around 3.18 kilo ohms. Okay. So this is the frequency. So this is the R2 value required to get a low pass filter, the cutoff frequency of 5 kilohertz. Okay. I hope you are getting this point. Is it fine? So now next problem. Can you take this problem? This problem appeared in GATE ECE 2012. Okay. The question is that the circuit is given. Now you need to identify the filter types with cutoff frequency, 3 dB cutoff frequency. So it is very easy. In 1 second we can solve it. Now can you tell me what type of filter it is? Low pass, high pass, band pass? What is this? And how can you find out the cutoff frequency omega c? So this is the network. And this network is responsible for cutoff frequencies, not this thing. This is just feedback path. It will give you the gain for that. But cutoff frequency will depend on this thing only. Okay. So omega c will be simply 1 upon R1 into C. Okay. This is the radian per second. So this is the cutoff frequency. Now whether it's a low pass or high pass, how to decide? So take one DC signal. So if I use DC signal, capacitor is open. For DC, capacitor is open. There is no connections. So no current will go through this side. Okay. So it is open circuit. So for DC or low frequency signal, it is behaving as open circuit. Right? So what will happen with these things? So output is completely 0. For DC, output is 0. But if we consider very high frequency AC, capacitor is behaving as short circuit. If it is there, so what is the output? That time output will be minus R2 by R1. Some gain you are getting. So high frequency signal can pass through, it will give you certain gain. But low frequency, the gain is output is 0. So low frequency cannot pass, high frequency can pass. So it is a high pass filter. So this is a high pass filter, as well as its cutoff frequency is 1 upon R1 into C. Okay. So it's very simple problem. It appeared in GATE ECE 2012. So these kind of problems are coming in GATE exams. Very quickly we can solve it. Within a second we can solve it. So remember that the network which is responsible for cutoff frequency will be this one. Is it okay? Fine. Now we'll take the next problem. So this is the problem. It appeared GATE ECE 2015. Again, you need to find out 3 dB cutoff frequency. So before that, can you tell me whether it is a low pass filter, high pass filter first? It's a low pass or high pass filter? Can you tell me? So don't be confused. So this end is grounded. So we can redraw the circuit little bit in this way. So this is negative, sorry, and this is positive. Okay. So there's a negative feedback here. This is grounded. So negative feedback is given by this network 10K 10K. So circuit is stable. Now this side I have one capacitor, it is grounded. Can I consider in this way? This is 10K. This is also 10K. This is your 0.1 microfarad. So what type of filter it is? So this network will give you simple one gain. This side just it will give you the gain. So non-inverting amplifier it is. And gain, what is the gain? Gain is 1 plus Rf by R1, 10 by 10, means 2. It will provide a gain of 2. That is okay. But this network, you are taking output across the capacitor, means it is a low pass filter. And you can note that there is no current is flowing through this side. This is 0 ampere. So it is not connected. So this potential, whatever potential here, it is there, that potential will be amplified here. Just you will be getting a gain of 2, and this filter type will remain same. So it is a low pass filter, it will remain low pass filter. So cutoff frequency will depend on this R and C, not this one. Be careful. Okay, so it will not work. It is not that 10 and 10, 20, no. Okay, so only 10K and this capacitor, they will decide the cutoff frequency. So omega C will be simply 1 upon RC. Okay, so here R means only this 10K and C is 0.1 microfarad. This is sufficient. So what is FC? FC is 1 upon 2 pi RC. Okay, I hope you can calculate it. So this is 1, it is 2 pi. R is your 10 into 10 to the power 3. This is kilo ohm, 10 kilo ohm. And it is 0.1 microfarad, 10 to the power minus 6. Is it okay? So this is 4, 10 and 0.1 will cancel, 10 to the power 3. So 10 to the power 3 by, this is 2 pi. Okay, so this is about 500 by pi. Am I correct? This is 500 by pi. So value will be around 160 kind of things. So exactly, I think it is 159.15. Are you getting this value? So this cutoff frequency, 3 dB cutoff frequency is very easy. FC in hertz, it will be 159.15 hertz. So you can see this kind of problem we can tackle within a second. But this is a tough problem coming in GATE exam. Okay? But generally in my institute I am giving more difficult problems. Okay? These are far easier problem. Okay? Now, the next problem. Can you solve this one? Please look at the problem here. Try to find out the cutoff frequency. Here also 3 dB cutoff frequency it is asked, that you need to calculate. So there is nothing that whether you need to mention whether it is low pass, high pass, band pass, anything. But can you tell me what kind of filter it is? Okay. So this where in feedback path this kind of block is there. Generally it is for low pass filtering. If this side is only resistances. Okay. But this side we have certain other elements. Right. So this is connected, 2C capacitor is connected here, 2R resistance also connected here, and R is connected here. But remember that this will provide the feedback, and because of that this op-amp is stable, and once op-amp is stable, output is finite, then this potential and this potential is becoming same. This is your 0 potential, 0 volt, because it is connected to ground. So this end is also 0 potential. Am I correct? If it is 0 potential, what is the current to this side? It's 0 ampere. What is the current to this side? Again 0 ampere. Because this is grounded, this is also grounded, this is grounded. No current flow, nothing is there. So these two elements, they will not contribute anything. We can remove these two things in our calculation. There is no impact on this output voltage. Okay. Though it is connected there, but they can't contribute anything. So we can ignore these two things. So it is now simply a low pass filter. Right? So only one resistance, it is like this. One resistance, op amp, and these two things. Resistance and capacitor. This is the output, this is negative, and positive end is grounded. This is your input potential, this is R and C. So already I have discussed that 3 dB cutoff frequency will depend on only these things. It does not depend on this one. This will provide the gain only. So what is omega C? It's simply 1 upon RC. Now you can calculate the FC. The linear frequency FC is 1 upon 2 pi RC. Okay. So all the values are given. So this is 1, it is 2 pi, R is 2K, 2 into 10 to the power 3. And what is C? C is given 1 microfarad, 10 to the power minus 6. So it will be 1000 by pi, 4 pi. That means I think it is 250 by pi, that kind of kilo ohms. Sorry, this is your in hertz. Is it okay? So 250 by pi, how much it is? Around 80 kind of things, less than 80. So exact value will be 79.58. That could be exact probably. So this is the answer. Is it fine? So this one is very simple. Okay. Now we can go for this one again. So can you find out the total things? Okay. Can you solve this problem? So this is one circuit mentioned here. Okay, this is one op amp, and this is another op amp given. This side one resistance, one inductor, and this side one resistance, one capacitor. Now we need to find out the output potential V naught. Okay. So I think we can solve this kind of problem later on. Okay. I can close this thing today. I'll take a live lectures again. So I will be discussing more problems. Not only these things, 10 problems, we will be considering more problems here. So I can continue if there are more students. Okay. So at least this problem, can you solve it? So this potential here, so V01. So inductor should be replaced by L into S or J omega L, whatever it is. Okay. And this one is 1 upon Cs or 1 upon J omega C. Okay. So this block, what is the gain? And this block, what is the gain? So they are cascaded. So first block, the gain is simply, this impedance is J omega L. Okay. So J omega L by R. So this is suppose R1. So this is R1 and with minus sign. And what is the gain for this one? Again inverting amplifier. This gain equals to, so it is R2. So minus 1 upon J omega C. This is the reactance of the capacitance by the resistance R2. So what is the overall gain? Overall gain is multiplication of these two. So total gain is product of these two. So minus J omega L by R1 times minus 1 upon J omega C upon R2. So omega omega will cancel out, minus 1 is a plus. Okay. So it is simply L by C upon 1 upon R1 R2. Okay. Now can you calculate the gain? So R is, L is given as 10 milliamp, 10 milli 10 to the power minus 3. What is C? C is 10 micro, 10 10 to the power minus 6. It is minus 6. And what is the R1? R1 is 10. And what is R2? R2 is 100. Okay. So can you calculate this one? So this 10 cancel out. This is 100, 1000, 10 to the minus 3. It is again 10 to the minus 3. So it will give you perfectly 1. So total gain, overall gain, this overall gain is 1. If overall gain is 1, output is same as input. So input was 10 sine 100t. So again you will be getting the same 10 cos 100t. Same thing. Okay. Because overall gain of this system is 1. Is it okay? Am I clear? So this problem appeared in GATE 2001 ECE. Little bit complicated, but not that much complicated. So here you need to find out exact expression for output voltage. What you will do? You will identify the stages. They are cascaded. The first stage, what is the gain for this one? Second stage, what is the gain for this one? Just multiply these two to get overall gain. Then multiply this gain times input voltage. This is the output voltage. Okay. Now we'll go for the next one, if it is clear to you. The similar question, it appeared in GATE 2016 ECE. This is a GATE paper. So can you solve this thing? Very similar problem. You should take care. So what is the first block? This is the first block and this is the second block. We need to find out the gain for individual one. Then we'll multiply these two. We'll get outputs. Okay? Overall gain. So we need to find out overall gain. V out by V in. So V out by V in, this overall gain will be product of these two. Okay? The first one, the gain for this one. Now can you identify what the type of this filter? The input signal is applied to plus terminal. Okay? That means it is a non-inverting amplifier. Okay? And second one, its output is fed to the second stage, but that is connected to minus terminal. It's an inverting amplifier. So this is non-inverting and this is inverting amplifier. Am I correct? For non-inverting amplifier, what is the gain? 1 plus Rf by R1. Means 1 plus this resistance is R1 by this reactance J omega L. Inductor's reactance will be J omega L and capacitor reactance will be 1 upon J omega C. It's very simple. Is it okay? Fine. So first stage you have got it. Second stage, it's inverting amplifier. What is the gain? Minus this Rf by R1 kind of things. So Rf means this feedback resistance. It is R3 minus R3 upon this reactance, this combination. So R2 and C, 1 upon J omega C, they are connected in series. So R2 plus 1 upon J omega C. This is the total impedance offered by this combination R2 and C in series. So that will be in denominator R2 plus 1 upon J omega C. Is it clear? It's a very simple thing. It's not that much difficult. The overall gain we can calculate quickly. So first block is non-inverting, 1 plus, that's, be careful, 1 plus R1 by J omega L. And second block is inverting amplifier. The gain is minus Rf by R1 kind of things. So R3 upon this impedance, it is R2 up plus 1 upon J omega C. Okay. Now you can replace. So what is the input? Input signal is given here, cos 10 to the power 3t 60. So it's the cos omega not cos omega t. So what is the omega? Omega equals to 10 to the power 6 radian per second. Okay. So L is given 1 microhenry, C is given 1 microfarad. So what is the omega L and omega C? Omega L equals to 10 to the power 3 is the omega, 10 to the power 6, and L is 10 to the power minus 6. It will cancel, it is 1. Okay. So omega L equals to 1. Again, omega C, I think again you will get 1 because omega is 10 to the power 6 and it is also 10 to the power minus 6 farad. So it is 1. So just I can replace. And all the resistances R1, R2, R3, they are given 1 ohm each. So can you replace? So this one is 1 plus 1 upon, this is J. This is minus, this R3 is 1, this is 1 plus 1 upon J. Is it okay? So what is simplification? So you can see that this 1 plus 1 upon J, 1 plus 1 upon J, these two will cancel. So overall value will be simply the minus 1. So this is the gain. So overall gain is -1 at that frequency. So at 10⁶ radian per second, that kind of signal is given. In that case, this system will offer a gain of -1. That's all. So it is not that much difficult. So just identify the blocks, then easily you can solve it. Okay. Any doubt, please? We'll solve more difficult problems. Is it clear to you? I hope so. We can move forward. Now this is the next problem. Can you solve it? So this is a recent paper problem. This problem appeared in GATE ECE 2022 ECE paper. Okay. What is the question? Question is that this gain function AV, its plot is given here. Okay. And circuit is mentioned here, this side. You need to find out these two values, R and C. R is this one, this resistance, and this capacitor. Okay, this is a little bit difficult. Okay, how can you solve it? And be careful about the axis. The plot given, this side in log scale, log base 10. This side also log scale. So log scale. This y-axis is 20 log dB scale. Rather, it is given in dB form. So how to calculate these things? So can you solve it? Or it is beyond your scope? Can you try? This is not an easy problem. So first, you need to understand this thing, what type of filter it is. It's a non-inverting type amplifier. This will give you the gain. And this is R and C. We are taking output across the capacitor. That voltage is amplified, so it is a low pass filters. And it is also, graphics are showing that. Low frequency, there is a high gain. As frequency is increasing, the gain is falling. So it is a low pass filter. For DC, what is the gain? Okay, that you can find out. So for DC, what is the gain? So this capacitor is open. So gain is simply 1 plus RF by R1. So DC gain for this one is simply 1 plus this R by 1. I am considering R in kilo ohm. Okay. Now it is mentioned here, these things, this level is given here. For at 0 frequency, what is the gain? Gain is 12 dB. So 12 dB gain. So actual gain, so it is 20 log of gain. Gain is suppose K. So 20 log of K equals to 12 dB. So what is the K value? First, you need to identify the K value. Okay. 20, you need to understand few things. 20 log 2. This is always giving 6 dB. Okay. Log 2 is 0.3. So 20 times of 0.3 is 6 dB. So it is double of that. So obviously it will be the square of this one, if I consider, then 2 will be multiplied here. So 20 log of 4 means 2 square, this 2 will be coming here, so this will be your 6 dB, 6 into 2 is 12. That means K equals to 4. So if the actual gain is 4, then in dB scale it is 12 dB. Is it okay? So the DC gain, I have said that 1 plus R by 1. So that should be equal to same as this K. K means here 4. So what is that? R equal to 3. 3 means 3 kilo ohms. Is it correct? I think it is fine. Okay. Now, can you solve the next part? Now, what is the C value? To find the C value, we have to use the information regarding cutoff frequency. Okay. The 3 dB cutoff frequency. So, this maximum level is 12. 3 dB less, that means this thing only. This is your 9. So it is cutting here. So this frequency will be called as 3 dB cutoff frequency. So 3 dB cutoff frequency is how much? 3. So log omega base 3 equals to 3. So omega base 10 equal to 3. Right? So what is omega? Omega is nothing but 10 to the power 3. That's radian per second. Okay, so from this graph we can identify that cutoff frequency is 10 to the power 3 radian per second. And that depends on solely on this network. Omega equals to 1 by RC. Is it okay? And which are? R is this thing 1 kilo ohms, this 1 kilo ohm only. Okay, so what is C? Then C easily you can calculate it. C equals to 1 upon omega C. Sorry, omega R. Okay, and if you replace everything, omega is 10 to the power 3 and R equals to 1K 10 to the power 3 means 10 to the power 6 means 10 to the power minus 6 here. That much farad means 1 microfarad. Am I correct? That's simple. Is it fine? Okay, so what is the answer? So we are getting R equals to 3K and capacitor equals to 1 microfarad. So answer A is correct one, 3 kilo ohms and 1 microfarad. So this is little bit difficult problem. But if you understand all the things well, then it is very simple things. Okay. Now I can give you some homework problem, and if you face some difficulty, then let me know. I'll solve this problem in next video. So this problem is basically, it is not about the filters, very simple thing, but can you solve this one? It appeared in GATE EE electrical engineering recently. Okay, can you solve this problem? And one more problem that I'll ask you to solve it, but if you face difficulty, then I'll be solving it in the next video. Please let me know this problem. This is mostly for semester purpose. If this kind of problem is mentioned, so this problem I have collected from Dorf book. Okay, the problem number 13.36. The circuit is given, this one, its corresponding plot, magnitude plot is also mentioned. This is generally called Bode plot. piecewise linear plots are mentioned there. But from here, can you solve these few things? Can you determine R2, C1 and C2 from this Bode plot? And can you identify the filter type? Anyone can please? What kind of filter it is? Low pass, high pass, band pass? From the magnitude plot only you can understand. What is the filter type? It's a low pass filter because for lower frequency it is a high magnitude, then it is falling, then it is kept constant here, fine. But at least for very low frequency its magnitude is high, about 32 dB, and high frequencies they are about 12 dBs. So high frequency and low frequency the gap is 20 dB. It's good enough. Okay. But from here, can you find out these values R2, C1 and C2? Okay. I am giving you it to your homework problem. If you can solve it, let me know in the comment section. And if you can't solve it, then also let me know. I can make a separate video on this problem only. If it is required, let me know. Okay. So I can stop here because this is more than 1 hour. So if you have any doubt, let me know in the comment sections. If any other topic, if you want video or a live session, I can go for that. So this channel is only for you. So if you are interested to learn certain things, I can help you. Okay. Thanks for watching.